Hi everyone, this video is for Math 97 or Math 95 support for 107. We are going to look at Chapter 1, just a quick review. I'm not going to do every problem in the workbook. You can try those on your own. I'll post the answer key though if you would like that. So the first one, adding integers, this should be from Math 92, but you may be rusty. So I want to make sure we just go through it really quickly. Obviously, this adding is just 5 plus 8 would be 13. But here we have some integers that are negative numbers. So we have -7 plus -2. So we're just going to add the digits and take the sign. So that would be -9. The ones here, C and D, have different signs, so that means you're going to take the difference of the two digits, just the number part, and then you're going to tack on the sign of the one with the larger absolute value. So here, -12 plus 4, difference of 12 and 4 is 8, and then -12 has the larger absolute value, so that would be -8. Same here, 9 plus -13, take the difference, and that would be -4. Just a little side note, sometimes the app that I'm using, it'll zoom in really big and I have to just pause the video and I'll fix that. So you might see it's just a little choppy for a second. So 1.1.2 from the workbook, we have subtracting integers, and mainly you're just going to subtract as you normally would, but sometimes we have different situations like this one down here, letter D, where we have that double negative. So usually people need to review that one. Again, if you're pretty good with this and it hasn't been that long for you, just go through and do them on your own, or you can skip these videos, just the review type ones. Normally I do grade the video notes and things, but for chapter 1, I'm making that optional. So for example 1.2, we have A, add 6 minus 12. So you're just gonna, again, you could rewrite it like this, adding the opposite, 6 plus -12. And again, you're just gonna find the difference of the two numbers, which would be 6, and the larger absolute value is 12, so we take that sign. So it's -6. Okay, now we're looking at letter B, and we have add 7 minus 1. So again, we could just subtract this like we normally would and get 6. But if we're going to convert that over to adding the opposite, which is sometimes useful, I don't require you to do that all the time, but we could just write that as 7 plus -1. But when we want to use the commutative property and move stuff around, technically we should be doing that. But a lot of people just kind of make that transaction in their head. So this would obviously just be 6. Again, you are welcome to speed the video up. I tend to go a little slow, but 1.5 times usually works well. If this isn't, been a while for you, you might want to take more time with it, and you're welcome to just do these on your own again. And anytime you want to slow it down, just pause the video. So letter C, add -12 minus 10, so we can rewrite that as -12 plus -10. And then we would just, they have the same sign, so we just add the digits together and take this sign. If we're $12 down, another $10 down, we'd be $22 down. So sometimes people get a little confused. They think that two negatives make a positive. They've learned that along the way. But when we're just adding two negatives, it stays negative. Multiplying is different. Also, letter D here is a little different case because we have two negatives sandwiched right in the middle. So what that means, again, we could write it any subtraction as adding the opposite. So we could write 17 minus or plus, sorry, the opposite here, which would be plus 13. So instead of minus minus, it becomes plus plus. Add the opposite. So then that just becomes a regular addition problem, and we get 30 for an answer. So multiplying and dividing integers, usually people remember this one pretty well. It's the adding and subtracting ones that pose more of a challenge. So these, I'm going to let you just go through and, just pause the video, try them, and I will write out the answers. And then if you're finding particular difficulty with any of these, I will do a couple in the video, but there are additional videos, extra help videos that go along with the book that I've posted in your Canvas modules. Okay, so hopefully you've paused the video and crunched the numbers on these. Do try to do problems and calculations without a calculator whenever possible, so that when we hit variables, you're going to have some tools that work well for not using a calculator, because we're not going to be able to type everything in as a variable. Sometimes you can, and especially if you have a graphing calculator, but not always. So A is 39. The answer to B is 7, because we have a negative times a negative will give us a positive. C is negative 40. We have opposite signs. We're going to have a negative. So an odd number of signs when you're multiplying in general will give you a negative answer. Always will give you a negative answer. B here, when we have an even number of negatives, we're always going to get a positive answer. So D here, 16 times negative 4 would be negative 64. Okay, now division works just the same way. You're going to just get 7 for 63 divided by 9. Negative 12 divided by negative 3. A lot of times we just use this fraction bar here for notating division. You're probably used to that by now. So 2 negatives, or even number of negatives, would be a 4. 33 divided by negative 3. We have just one negative. We have two different signs, so that's going to be negative 11. And negative 40 divided by 8 would be negative 5. Now for this section and even the fractions, I'm not going through how I would normally teach that from scratch like I would in a Math 92 course. So just keep that in mind, that we want to just review this, but there are more supports online in your Canvas module. You can go through piece by piece and get more details. If you're not finding it from those extra videos I posted, then please let me know. I'm happy to meet with you on a Zoom meeting and go through more, or if you just want me to make a video specific to a certain problem, you're always welcome to ask. Okay, now here's fractions, everyone's favorite, I know. So fractions should always be reduced. We want to really pare it down to its simplest form. Simplest form does not mean putting it in a mixed number. Sometimes that gets a little confusing. Simplest form or reduced means that there's no common denominator or common factor to the numerator or denominator. So for example here, example 1.5a, we would reduce 12/16. So we have a common factor of 4 that goes into both of those, and so we would just divide by 4 over 4. That's like dividing by 1, and we would end up with 3/4. So B is a little bit larger and more to work with, but go ahead and just try that one. See if you can do that. It's classwork. We're not really in class, virtual classwork. So this one's a little tricky because of the bigger numbers, and you might not recognize the factors that go along with it, but 119 would actually break down to 7 times 17. And 68 actually breaks down to 4 times 17. So that's one thing for the bigger numbers till you get used to familiarity with the numbers that you're using. You can use your calculator to kind of play around with that. Then we see that 17 over 17, that would really reduce to 1. So we're left with 4/7 for our answer. When we are multiplying fractions, we can be efficient, more efficient or less efficient. Less efficient way is just multiply across the numerators. You can certainly do that and get, for this one, we would get 2 over 24, and then we could reduce it, divide by 2 over 2, the common factor, greatest common factor if we can figure that out, and then we would get 1/12. However, we can also do this problem different ways. I'm going to go ahead and erase that. So especially when we get bigger and bigger numbers, we want to streamline it. So we could take any top with any bottom and reduce it before we even multiply. I call it simplify before you multiply. So this 2 into 2 is 1. 2 also goes into 8 4 times. And then we can go ahead and multiply across the top, across the bottom. We get the same answer. It was already reduced for us, but do double check in case you missed one. You always want to try to make sure you hit the lowest, okay? So B, 1.6b, I have 5 over 55 would be 1/11, and so it's on the diagonal. Even if I had another fraction off to the right, I could kind of skip over as well, as long as they're being multiplied. You never want to do this when you're adding or subtracting, just multiplying. 4 into 4 is 1, 4 into 16 is 4, and now multiply across top, across bottom, comes out much simpler. I can just quick do that in my head rather than having to do all these extra steps of multiplying first and then simplifying. It just streamlines it down. It's already broken apart for you to see the smaller pieces. For dividing fractions, we are going to rewrite the fraction that comes after the division sign as the reciprocal. So we are going to keep the first factor as is, so 10, and we can write it as 10 over 1. We're going to change the division sign, and then we're going to flip around this second factor to be 2/3. That's called the reciprocal when we do that. So again, I'm not teaching this from scratch. In Math 92, I would go through all the components of why we do that. Hopefully you've already had that. If you have not, just let me know, and if you're curious about that, I can send you a video or make one that explains that. So then we would just now multiply, and we would get 20 over 3. And we're actually going to just leave it right like that. We don't want to change, or we don't have to change it. We could make it be a mixed number because it's an improper fraction, but it's totally okay because it has no common factors to the numerator or denominator. So we can just leave it like that as an improper fraction. We often do that. So for B, pause the video and try that one on your own, and then I'll go ahead and do it. Okay, so hopefully you've worked on that one, 5/14, and we're going to change that division to a times, the reciprocal, 12 over 25. And now we're going to reduce on the diagonal for each of those. So now I have 1/7 times 6 fifths, and that will be 6 over 35, and we'll just leave our answer just like that. So I'm going to stop this video here, and then we'll take up with the next part, adding and subtracting fractions that This one's getting kind of long, so I want to make that a separate thing because that's usually more challenging for people. So I'll go into a little more detail. So even if you've had fractions before, you may not have learned some of these methods.